Hi, my name is Aaron Harwitz, and I'm going to talk to you about one of my big philosophies in life. So we started out as a making culture, right? If you needed a spear, you went out, you got two rocks, you chipped them together, you made an arrowhead, and you lashed it to a stick. And if you needed a loincloth, you went out, you took that spear, you killed a bison, you skinned it, and you tanned it. And as our needs became more advanced and our manufacturing techniques became more advanced, people began to develop skills, and craftsmen emerged. And when the Industrial Revolution hit, we moved to mass production of goods within factories, and slowly but surely, those craftsmen faded into the background. And our culture, as a result, shifted from makers to consumers. But right now, we stand at the cusp of a really interesting time in history. What techniques that were otherwise impossible and things that we could never make before, everybody in this room can do in their very own homes. We can print plastic components from our desktop computers, and we can make just about any type of hardware device we want with open source technologies. There's just one thing that troubles me about all of this. It's a phrase I've heard over a dozen times this past year. Someone will come to me with a brilliant idea, followed by the question, where do I find somebody to build this? And every time I'll answer with the same response, why don't you build it? And I'm always met by apprehension, but this is my philosophy. Just start building. And here's why. When you have a purpose, you can learn whatever skills you need to achieve that goal. If you have something tangible to apply your learning to, you can visualize the progress you're making and learn out of love. And the reason I say this with so much confidence is that a year and a half ago, I was asking myself that very same question. Where do I find somebody to build this? As part of Design for America at Northwestern University, I heard about a project called Jerry the Bear. It was a concept on a Post-it note. And basically, it was a robotic teddy bear to educate children with type 1 diabetes how to take care of themselves. Now, I was immediately attracted to this idea because when I was a child, I was diagnosed with human growth hormone deficiency, another type of endocrine disorder which basically equates to injections throughout your childhood. Now, for diabetics, this is increased tenfold. You're injected up to 8 times a day. Your fingers are pricked. The school nurse is pulling you out of class. Your parents are waking you up in the middle of the night. And so I hopped on board with 2 feet to get this Post-it note into the hands of those kids. There was just one little problem. None of us knew anything about circuitry, resistors, transistors, phototransistors, diodes, robotics, mechatronics. I didn't even know what the word mechatronics meant, let alone how to program pieces of silicone and ceramic and bring them to life. What I did know is that I believed in this idea, that I loved this idea, that I knew it had to be made. So over the next 10 weeks, we had a crash course with an emphasis on the word crash. I can't tell you how many times my programs would not work because I was missing a semicolon, how many circuits I made that outright didn't function because I had soldered a wire to the wrong pin, and how many of those ended up catching fire and smoking in my face. At the end of those 10 weeks, though, we had this. Here's a picture of our first prototype. Certainly a little rough around the edges. It has the eyes of a Furby, and what you can't tell from this picture is that its body is sculpted from rock-hard modeling foam, and the only thing that's holding its head to its body are 2-inch metal nails. Just details. We had created something that we had known nothing about before, and let me tell you, that is one of the most empowering feelings that exists. I began to realize how the same piece of information taught within a classroom can take on a whole new meaning when applied to something real. A line of code as cryptic as TCCR greater than 1 can be demystified from a way to control the digital port registers of a microcontroller to the way to make a circuit laugh. Now, I had discovered a new type of education, one driven by purposed projects, and I was hooked. I didn't want to stand for taking any more classes in college that didn't give me this same sense of fulfillment. So I did at the end of that year just about what one individual does, exactly one, in the School of Engineering, McCormick School of Engineering and Applied Sciences. I changed my major and I made up my own with quite possibly the longest title you've never heard. It's called Mechatronics and User Interaction Design. And it's basically how people play with robots. And So I kind of like to say I majored in this Jerry the Bear in college, and at the end of the day, it's kind of true. And so when the time came to begin working on Jerry the Bear, this is the prototype we have now, a lot cuter, but working on this full-time as a business, it took me about 30 seconds to convince my teammate Hannah Chung, who's sitting right there in the audience, to move to Providence with me, and now every day is a Jerry day. And interestingly enough, the hardest part of this whole process, getting from there to here, it wasn't the circuitry, it wasn't the robotics, certainly wasn't convincing my teammate to move to Providence, and it wasn't the countless hours of failure. Don't get me wrong, those were difficult. But the hardest part of this whole process was taking that first step, believing enough in myself that I had the power to learn these skills. Now, taking that leap is what breaks down a skyscraper of information into a staircase. Now, there's no elevator to the top, but once you take that first step, the second becomes easier and the third becomes faster. And invariably, you will stumble and trip on your way to the top. But who wouldn't when you're climbing the staircase to the top of a skyscraper? So the next time someone comes to you and asks you, or the next time you ask yourself, where do I find somebody to build this? Remember these 3 words. Just start building. Thank you.
I am going to talk about some of the lessons to develop a clean technology startup. One thing that I want to say before we get started, so I do have a bit of a stutter. Sometimes it is going to take me a little while longer to say something, so if you can, please just bear with me. But anyway, just to dive in, here's the problem we are hoping to solve. Most of the apartments that are heated with steam, they are actually significantly overheated. If you run through all of the numbers for all of the apartments in the New York City area, you are going to get a total of over $500 million every year is just wasted from this overheating. So why this is because of the steam systems that are used to heat most of these sorts of buildings. It was a great technology for the time, but since it has been installed, it just really hasn't changed all that much. And if you look at this little cartoon here, you can see one of the major problems is you only have one point of control for the entire building. You can either have the boiler on or you can have the boiler off. You can either have heat or you cannot have heat. How we want to solve this problem is to have an add-on that we can have for the radiators that are in the building to make each of them smarter and more thermostatically sort of controlled. So we have three key components of the system. We have an enclosure that is going to let us turn off heat transfer. We have fans that are going to let us turn heat transfer back on. And we also have a monitoring system so we can decide if we want heat or if we don't. So we started off by seeing if we could actually build something like this and then have it work. So this is actually a system that we built and installed in my co-founder's apartment since he was just sick of the overheating problem. You can see we have a before shot and an after shot showing that the system actually works. And you can see the whole system works pretty well to eliminate the overheating. So we learned some very interesting things from the prototype phase. Two of the points that I want to emphasize is that if you want to solve a problem like this, you you first have to do your homework. So for us, that actually meant looking back at the laws of thermodynamics and then seeing how the heat transfer in a building something actually worked. Then the second point, really parallels the lessons of the first talk. Is if you want to make something, you should just go ahead and make something, and then you can get the actual data, which is the best way to show that your idea actually works. So on the strength of the data that we got from the prototype, we were able to get funding from the New York State Business Plan competition and from Columbia to install a full-scale system, for a pilot. What was nice is we found two very similar buildings side by side, so we could have a control building, as you see on the left, where we just look at the temperature throughout the building, and then we actually have our system installed on the building on the right. So what we found out from the data from our pilot is it is very, very promising data, but it's not quite as good as we would have hoped. So what you can see here is this shows the temperature for all of the rooms throughout the building over a 24-hour day. You can see for the reference building on the left, you have more of the overheating and you have more of the variations of the temperature. On the right, what we showed our system was able to do was to help stop the overheating for some of these apartments and to help smooth out some of the temperature variations. If we look more closely at the data that we have, what we're able to see is that there are just some of the apartments that are too hot for a system just because we couldn't get enough of the insulation in the apartment. There are other apartments that were just too cold because the size of the radiator wasn't large enough. But we did find some apartments where we had the right amount of insulation and the right amount of heat. Then you can see we're actually able to do something to control the temperature there. So then some of the lessons that we learned from the pilot is if you have all the theory that you want, so that's great, but you have to get it out there, have to see how it actually works out in the real world, because there are going to be some things that you just weren't able to see when you're working working back in the lab. So you're going to screw up. You're going to want to be able to make some changes. So you really want to have your pilot set up so you are able to make those changes. One of the most surprising things for us as a group of engineers was to find out that so we were in the customer service industry now. Since we wanted to install this in someone's home, it is something they are going to want to have in their home. And if they say, I don't like the case because it's black, I don't like the color of the light on this, that is something that you are going to have to listen to and have to take into account. So then where we are now is we have the data from the first pilot that we did. We have determined a site for a second pilot, and so we're now looking to see how we can make a large quantity of these for the next pilot and for eventually for a product. So some of the lessons that we've learned from the development side of things, certainly we have screwed up a lot along the way, and then that's okay. That is just something that comes with the territory. But the moral is you just have to keep on trying and see what you can do. Just have to keep on putting yourself out there. So one last slide. Since this is supposed to be more of an inspirational talk, I decided I would end with some advice for anyone who wants to try their hand at a startup. So the first thing I would say is that you have to have a problem that you're trying to solve. Even if you have the greatest technology ever, if there isn't a market for it, then it isn't going to make for a very good startup. Second, you should take advantage of all of the resources that you can get. So especially if you want to get free money for your startup to fund these kind of projects. Something that is nice is that so far we haven't had to raise any sort of venture capital because we've been able to fund this just through various grants and business plan sort of competitions. So then finally, no one is going to be able to do this all on their own, so you have to have the right team. And with that, I just want to thank everyone. So on my team, my co-founder Marshall Cox is here. Our advisor John Kamissis is also a co-founder. Then I also want to thank Mike, who is our design engineer, who has done all of the real work. So that's it.
So I want to talk about some of the technology that's coming out of Africa right now. And my favorite example of inventiveness in Africa is this guy right here. He wrote a book called The Boy Who Harnessed the Wind. This is a 16-year-old kid from Malawi who went to his high school, got a physics textbook, learned basic mechanics and electronics, and built a wind turbine out of wood, scrap metal, and spare bike parts. And there are incubators and accelerators popping up all over the continent to support entrepreneurs like William. And this is Nairobi's first startup weekend that happened a couple months ago. These are the guys who won. There's so much cool stuff that's going on right now. And here's another example, prepaid electricity meters, giving access to millions of people in rural Africa to electricity. Same way it works for their cell phone. They can use the phone, they can get a code, punch it in, and then they get electricity. And the impact of cell phones in Africa across sectors has been really profound. Of the 1 billion people in Africa right now, half of them, 500 million, have a cell phone. And some really cool stuff is going on with that. There's a startup called MedAfrica that's enabling the 7,000 doctors in Kenya to serve 40 million people. And Sun Culture is really proud to be part of this growing movement of companies that are using technology to solve social problems. And we believe that our product, which is a solar-powered drip irrigation system, has the potential to dramatically improve millions of lives. The problem that we're solving is Africa has 27% of the world's arable land, but only 6% of that is irrigated compared to almost 40% in China and India. If we want to get Africa to the point where it can not only feed itself but become a net food exporter, irrigation is absolutely crucial. And my co-founder is going to talk a little bit more about our technology, how we're going to make that happen.
Thank you, Charlie. So I will talk more about the technology of Sun Culture system. Our irrigation kit is an all-in-one package for farmers that is easy to use and inexpensive to maintain. Thank you. A similar technology was used by Stanford Stanford studied for the Solar Electric Light Fund, and they they pilot this on Benin, Africa, which is a semi-arid region that is really similar to the areas that we're seeking to serve with sun culture. So we learned from the Stanford experience and we modified a bit their system to be more affordable and efficient to our customers. Here we have a video rendering our proposed system. Play the video.
Yeah, let me see if I can get the video going.
Okay, so basically what our system is that we take the water from a river or a well, and then we use solar panels to power the electric pumps, and then the water flows to an elevated tank, and then from the elevated tank, it will go all the way to the root crops by drip lines. Here we can see this elevated tank that acts as a mechanism to storage energy, and then we also see the solar module that it's the one that powers the electric pumps. And in this video, we will surely see the different type of crops like tomatoes, corn, that could be used with our system. So what is really interesting about our system is that we can use vegetables, fruit, flowers, and different type of staple crops like corn. And then what is amazing about our system is that we increase the crop yields in up to 100%, and we're using less than 80% of water that we'll be using with normal, like furrow irrigation techniques, which are the traditional techniques that we use. And also, a really interesting thing about our system is that we are also improving. If you use the diesel pumps, you will save up $3,000 during the life cycle of the system. And then there will be an elimination of the environmental and health impact issues that are associated with the use of this conventional fuel. Our team started working on this system for about like 5 months ago when we entered the social venture plan competition at NYU. It has really helped us to change the way that we were using our idea. It was like a really abstract concept that we have. And in this just 5 months, we have like a much better understanding of what we're doing. And it's an early launchable idea that we have now. And that's why over the summer, we're going to Nairobi to start our pilot of our technology. It's really exciting. And so what we are trying to tell you is that there's like a tons of different innovations all over the world. As you can see, there's like amazing things happen around Africa. And this is a really exciting time to be an entrepreneur, just not here in New York, but all over. So I wish that we have explored that into you. And thank you so much for paying attention to us.
You're a soldier running through the field of battle, and you get hit with a stray bullet. What do? Do you wait 10, 15 minutes for a medic to come to you and wait while in vain they try to stuff gauze into the wound and stop the bleeding? Or do you pull a simple can off of your belt, put it to the wound, and in under 10 seconds the bleeding is stopped and your life is saved? Imagine again you are old at the end of your life and you're bedridden. You have unhealable bed sores. Does your doctor wait and maybe the wounds heal, maybe they don't heal? Or does he take one can, spray it onto the wound, and that wound heals? Again, what if you're a child? You're running and you skin your knee. Do you put a bandage on it and wait the 14 days for it to heal? Or do you spray it once and in under 10 seconds it's sealed off and the wound heals in under 3 days? That is my product. That is Metagel. Ladies and gentlemen, my name is Joe Landolina and I am CEO of Suneris. So tonight I'm going to talk to you about how I developed Metagel and how everything came to be. So about Suneris, last year when I was a freshman at NYU Poly, I was going through going through the process of getting into Poly, and their icebreaker was to come up with an idea that would help a superhero, Batman. And it was kind of a stupid idea, and we thought, well, what if we could take a product that you just give to Batman and he snares a bad guy with a rapid forming gel? It was a completely stupid idea. But from there, I got into the NYU Stern Business Plan competition. And what we did is we decided that what if we could take a gel like that and put it onto a wound? If you could seal up a wound instantaneously with something that replicates skin. So from there, I met Isaac. He's actually sitting in the audience right here, and he deals with the business side. I study biochemical engineering at Poly. And this is our team. Isaac is graduating this year. I'll be graduating with my master's in 2014. And I'm going to talk to you a little bit about Metagel and what it does. So now, I have worked with rapid-forming polymers since I was in the beginning of high school. I did research on it, actually at Columbia. Well, what we did is we decided, well, what if you can take the actual polymers that make up your skin, have plants grow them, break it up into little pieces so it's liquid, and then immediately when it gets onto your skin, it snaps back together and seals over the wound. So in a little bit more detail, this is a little bit in depth. Basically, Metagel works in two parts. The first is a hemophilic polymer, and what that means is the second it touches blood, it grabs it up and stops the bleeding. But it doesn't stop there. The structural polymer, which you can see in green up there, it actually replicates your skin. So your body thinks, well, it's just another part of your body. So it stays on for up to 14 days. You don't need to change it out. And it heals you faster. You don't need to change it. You don't need to deal with anything. It just completely heals the wound for you. Now, with Metagel and all of the embodiments from it, we can actually replace 80% of everything in the wound care market, right? That's treating burns, that's treating wounds, bed sores, all of the above, right? And I mean, the 20% others are the things that actually like to bride the wound, which Metagel does not do. It's just a quick sealant, right? So again, here's another figure that shows the leading competitors in the market that go from liquid bandage up to the very advanced silver microbials, things like QuickClot. What we do is we package everything into a single application, right? Everything else here, you need to either use it with gauze, you need to use multiple packages, you need to do reapplications once a day, twice a day. With Metagel, you spray it on and you forget about it. So what we're trying to do is we're trying to make one product that can solve all of your needs wherever you need it. So now getting back to how I developed Metagel and how we got through this. The very first stage was just to go and kind of pitch the idea around. So we started off in the Stern Venture competition. We really didn't know what the hell we were doing. So we started out, and we were a finalist in the Stern. We did not win, but we won the Poly Invention competition. That gave us $5,000 of seed funding and the network that we needed along with the Stern competition to just kind of start making the contacts that we needed. So we got out into the market. Originally, we were just looking at the EMS market, right? Trying to get it into the military, trying to get it onto ambulances. But that's kind of, with the FDA, everybody thinks, well, it's going to take millions of dollars and multiple years to get this done. Well, the EMS market, it doesn't take that much. It takes about a few $100,000 and about a year to get it approved. And we're already well into that process. However, we've realized almost recently that there are multiple other markets that you can go into with a lot less regulation. So the very first of those is the veterinary market, right? We can get into the veterinary market with about $10,000, right? It's not, the regulatory $10,000. So we can get a product onto the market, and we can open up revenue streams, before or while we're waiting the 6 months to a year that it takes to get through the FDA, right? Then on top of that, Metagel is also a perfect platform because it's completely organic. It's completely plant-derived. So what we can do with it is we can take any drug, any therapeutic protein, and inject it into the gel. So you don't need to use a topical cream that will go away. You don't need to use pills. You can put it right on a wound and treat it directly as the cells are healing. So as the cells grow into the gel, they absorb the drug. So what we can do is we can tackle things like diabetic foot ulcers. And in cows, they have something called hairy heel warts, which are about the same thing. We can tackle bed sores. We can tackle wounds that would otherwise not heal, or you would need a treatment that costs tens of thousands of dollars. All right? And then what Metagel is also for is we're looking at DARPA, kind of in the long goal. Right? So right now we have a small sprayable product that can be used on animals, and it can be used on small wounds for humans. But the end goal is to be able to take something that, you walk into a minefield and you get a leg blown off. What do you do then? So that's kind of where we're going with Metagel. So basically, that's the process that we went through, and I'll end there. This is my email address. If you guys have any questions, I'll be here afterwards. And also, you can send me any emails with any questions.
Great. So my name is Deborah Bereviches, and I grew up originally in Mexico City in a community that didn't exactly encourage women from doing science. I learned to hide my love for math and physics because my parents, my school counselors, and everyone told me that it wasn't a career for girls and that I probably couldn't do it. Until I finally couldn't repress those wishes anymore, and I applied for a scholarship to the US, and I transferred, and finally, 6 years later, I ended up being the first Mexican woman to graduate with a PhD in physics from Stanford. And I share that with you because I'm a living example of the fact that if you put your dreams and your mindset into something, you can make anything come true. So let me tell you about my research. I work with waves, all sorts of waves, electromagnetic waves, sound waves, water waves, etc. Now, we all know that waves tend to scatter, to disperse. So it would be pretty weird if we saw all of a sudden that when I shout my voice in Grand Central, the sound waves, in this case my voice, would spontaneously arrange themselves to focus only at my girlfriend's ear so that I could tell her and only her a gossip or a piece of news. It's not only the case with our voice, but the dispersion of waves is pretty ubiquitous. The same thing happens with wireless signals. So when you communicate with your cell phone, the antenna sends signals that spread out in space. Therefore, anybody in the middle of the wave can actually intercept the signal. Now, what would happen if we would be able to, instead of having scattered communication, to be able to control waves and actually focus them at a single intended location in space? Now imagine in one emergency day, for example, that Mayor Bloomberg is in one building in office 714, for example, and that for security reasons, he wants to communicate only with the head of the NYPD, who is sitting on another building far away from it, and no one else on the way to be able to intercept the message. That would be cool, wouldn't it? Another cool application, if we were able to focus signals, would be, let's say you're at the UN or in this auditorium, and I wanted to focus my speech, in this case John's speech, in a different language at each one of the seats. So here we see in Chinese, English, and Spanish. Wirelessly, each person would hear the message or the speech in their desired language without there being any interference with the person in the next seat. Another application would be underwater acoustic communications. So let's say that I want to communicate with the friendly submarine, but I don't want the enemy submarine that's right nearby to be able to get the signal and decode it. I would just physically focus my signal in a specific location. Another more lighthearted one would be in entertainment. So let's think about the eternal marital fight about watching TV. And in this case, we would have the husband watching his own TV show and the woman watching her own TV show without there being interference in the audio or video. Imagine also if you're driving your car and each one of the persons in the car could listen to their own radio station without there being any interference. So how do we do this? I showed you what the problem is. The solution is using a method called time reversal. Unfortunately, my movies didn't load up in the computer, so this was a movie about a pencil being sharpened, being unsharpened back into being a complete pencil. Because when people hear the word time reversal, they often think it's reversing the processes that we see in nature. Well, not really. If used in signal processing, oops, sorry about that. Imagine that I send the word hola to you. What you would first get is the H, then the O, L, and then the A. Well, time reversing it only means to actually send if you time reverse it, you would send the word ALOH, A-L-O-H. So time reversing it only means if we have a whole signal here, not just the word hola, but a whole message, a whole speech, time reversing it would only mean flipping it backwards. So putting first whatever I received last. That's as simple as that. Now, why is time reversal important? For the engineers in the room, you probably know that there's a diffraction limit, so that we can only focus things up to a certain point. But time reversal has an incredible result, which is the fact that it allows you to focus waves in space. And in cluttered environments, it focuses them so well that it transcends the diffraction limit, and it focuses to within half of a wavelength of the original signal. So just imagine here the red means high energy and the blue means low energy. So medical applications could use this when you wanted in lithotripsy to destroy a kidney stone. You would focus only on the kidney stone and not damage any of the surrounding tissue. Unfortunately, this is a movie, a computational simulation that I wanted to show you, but I wanted to show you live what time reversal looks like. So pretending the movie is going on, John here sends a signal, a very brief hello, that scatters all around the room, and it bounces with the walls and with the obstacles in the room on the way to each one of those audience members. Now, each one of those people there, Ting, David, Marta, and Dana, are recording all these echoes that are being transferred in the room for a long time. In the backward phase of time reversal, forget about that now. Maybe it works. No, sorry. In the backward phase, what you would see is now each one of these audience people will send the time-reversed version of the wave they recorded. And after a certain waiting time, you would see the waves scattered and in a complex pattern, but after a time equal to the recording time, the waves will focus only back at John's location, and nowhere else will you be able to get any interference. So the communication protocol would work like this. We would have these three guys be receivers. So they all have a microphone, just like mine. In the forward phase, each one would send a blip, and John would capture all the recordings and all the bouncings of the wave. The other one would send a blip, but because the location is different, the bounces would be completely different. So these echoes will get recorded, and then the third one will do the same. All John has to do is time reverse these signals and send them back into the room, and simultaneously each one will focus at its intended location. So then when John wants to send an entire message and not just a blip, he would simply compose an entire signal out of these self-focused beams. So very briefly, we did this live in Toronto in the university, and we were able to focus. We were students waiting at each floor of these different buildings, separated by about 2 to 3 kilometers, and we were waiting for a signal. The students in the undesired floors did not get any signal whatsoever, just noise. But the people at the desired and intended targeted floors would get the entire communication. So it works, and the cool thing about time reversal is that in normal environments it focuses, but in cluttered environments it focuses even more. So why do I think it's amazing to have a university to do research and jump to entrepreneurship? At Stanford, I was very lucky to make use of the facilities. We had expensive wireless equipment. We had the libraries and archives. I could collaborate with top scientists, and I actually carried out my experiments not only in a parallel computer cluster, but also live at the Naval Postgraduate School in Monterey. Finally, the Office of Technology and Licensing at Stanford helped me assess the market impact and the market interest of my application, and we're going through the patenting process. Thank you for your attention.
So what my software does is it converts a hearing person's voice into text and it converts the deaf person's text response back into voice. So before I go ahead and talk more about my product, I want to talk about the problem I'm trying to solve. Okay, so to do that, I want you guys to imagine a scenario in which you're trying to call a doctor, a loved one, a lawyer, and you want to have a private phone conversation. However, in this scenario, you can't call the person directly. You have to call a call center first. And this call center operator will relay the messages back and forth between both parties. And also, in this scenario, there's a procedure involved to relay that conversation back and forth from both parties. You need to know special code words for relaying the message and also for ending the phone call. So it's a complex procedure, and also there's zero privacy. And that's currently how the deaf people make phone conversations currently. Just to illustrate the point, I took some information from the New York Relay website, and there's 6 processes right now to facilitate a phone call for the deaf hearing. With DefTel, it's actually just a one-to-one phone conversation. The robot you see in the center is just a visual representation of my software. So just to give a little history of DefTel, I'm not deaf, nor do I know anyone who's deaf, but I created I entered a programming contest early last year for this telephone software company called Twilio. And I created this technology that converts voice to text and text back into voice. And I submitted it for the contest. I didn't win. And then I forgot about the entry, went back to my previous startup. And months passed by, and I kept getting these emails, people asking from the deaf community saying they really need this software. And finally, this one email came that was really compelling, and you can see it over here, and it really made me stop what I was working on currently and seeing, okay, let me see if I have something here. So to do that, I said, okay, let me make a quick web page on deftel.com and give a quick description of what it does, and put a field there to get email addresses. And then I created a Twitter account, and in the bio, I linked back to the DefTel webpage. So in the first hour, I started following around 600 people on Twitter who I thought would be potential customers. Within that first hour, 457 of them actually came back to the website, and they actually entered their email addresses, and they tried to actually contact me through other means. Somehow they would find my phone number, they would find other email addresses I have, and really try to get in touch with me and let me know that they want the software. So the next step, I said, okay, look, let me create the prototype, and I'm about to play a demo for the software I created. I don't have a live projection screen right now, so I created a demo video yesterday, and so we'll play for you right now. Hey, how is everyone doing today? I'm going to make a demo of my DefTel app for the show. You can see that I have the DefTel app loaded on my iPod Touch. I have my smartphone, the iPhone right next to it. I'm going to call my DefTel app from my iPhone. It doesn't have to be an iPhone, it could be any phone. Going ahead, placing a call from speaker. Going to answer the call. Hey, how's everyone in the audience doing today? So I'm going to go ahead and respond back with the keyboard. I'm going to hang up over here right now on the iPhone app. And you can see it ended the call on my phone too. So that's a really interesting feature of DefTel app. Another thing I want to demo, I'm going to make a phone call to my iPhone.
Everyone write down his number.
It gives you a message saying it's calling the phone. Now I'm going to do something interesting here. I'm going to decline the call. voicemail. I want to show you a cool feature that happens next. So now it actually differentiated between a normal voice and a robotic voice. So my software says, okay, robotic voice just picked up, and it was a voicemail. So it plays a message for the deaf person we just saw before, letting them know that it picked up, the voicemail picked up, and it left a voicemail for the user. So as soon as I leave a voicemail and a notification pops up on my iPhone, looks like I might have done that, yep. I'm going to play what my DefTel app just sent my iPhone. So that was an automated response created by the DefTel app. It spoke the person's name, who is calling them, and it lets them know, please give them a call back. So that's currently my phone service right now. What you don't see in this demo is it currently supports more than English. It supports Spanish, German, French, and Mandarin, and we should be able to support those languages in the future. Thank you. If you can go back to the PowerPoint. Okay, so one thing more I wanted to add to that, that's DefTel, where we're connecting hearing people to deaf people. Also using the same exact technology over here, I also built out the prototype of a universal translator, where mentioning those languages I just mentioned, people can speak back and forth between both. So someone from China can speak Mandarin and hear Mandarin, and someone in the United States can speak English, hear English, using that same technology I built for DefTel. So if you guys have any more questions or interested in emailing me, it's my email address, my Twitter, and my Facebook. Thank you. Yeah.
So this is the problem we were trying to solve, was that young guys feel really uncomfortable wearing business wear. So Ministry of Supply is really a line of men's clothing based on performance fabrics. And we're starting with dress shirts because we feel like that's one of the most uncomfortable parts of a men's attire. So underlying our whole theme of our company is we're inventing apparel. So one of the key things is because we're engineers, we're kind of outsiders to fashion, and that gives us a really unique perspective. So this is the current approach. These are designers, from high fashion design firms, creating clothing that is often inaccessible. Like, a lot of people don't feel like they could actually wear this on the streets. Another thing is, Fashion Week was about a couple weeks ago, and that was for the fall and winter line. So you can see that these products take months and oftentimes almost a year to go from concept to the racks. And so we thought that we could really change it by taking a totally different approach to creating clothing. So we're a team of engineers. So I started chemical and biological engineering. My partner, Kevin, studied mechanical engineering and product design. Our two other co-founders, Kit and Aman, they had worked in finance and consulting before. They're now MBA students at MIT Sloan. And it was really interesting. They were working on a separate concept, creating the exact same thing, creating business wear based on performance fabrics. We had a product. It just seemed like a nice marriage to have business and engineering meet together. So one of the things is, in the fashion space, like we were saying, is designers telling people and dictating what looks good. And we wanted to change that. We wanted to ask customers and really see what they needed in their products. Kevin and I had both worked for product design firms. Kevin worked at Apple designing the iPhone. I worked at IDEO doing a lot of human interfaces for medical products. And the things that we learned there were that it's all about a relentless attention to the customer experience. And that's what's driving our product. So we talked to our target customer. This is Chris. He's a 27-year-old oil and gas engineer in Houston, Texas. He works out in the field in the day, but he also teaches ballroom dancing classes at night. And so he loves our product because he can wear our moisture-wicking dress shirts from the field to the dance floor. Now, the thing is, for Chris, he really needed a product that was versatile. He wanted a shirt that would keep him dry, would stay cool, but also he just doesn't have time to go to the dry cleaners. So he wants something that's easy to take care of. But importantly, like currently in the fashion space, they try to do this one-size-fits-all method. And what happens is the clothes just don't fit anyone well. And so we tried to focus on creating a fit that works well for our target demographic. Now, we're engineers, and so we couldn't help but bring some of the lab tech to clothing. And so this is some stuff that you'd never see in a conventional dress shirt. This is actually something called photogrammetric strain analysis. It's a method of basically figuring out how the skin of the body stretches. And what we did from that is we mapped stretch panels to our dress shirts. So we're able to create a shirt that moves dynamically with our wearers. It doesn't come untucked. And we're actually able to quantify how much our shirt wrinkles, how much it comes untucked. And the best part is it fits a lot of different body types, but still gives that tailored and trim look. We also did things like infrared thermal imaging to figure out what the hot spots are in our shirts. We create undershirts as well. And this engineering analysis really educated our design. So it's not just intuition, it's driven by the empirical data. And that's really important to our product because it's actually functionally better. One of the things is, and it goes back to human-centered design, is creating an entire experience. So we found out that a lot of guys, they loved our dress shirts, but they're wearing cotton undershirts with them. And that just doesn't make sense. Because what happens is a cotton undershirt, for any of you who's gone running a cotton dress shirt or a cotton shirt during the summer, it'll soak up your sweat and it takes forever to dry. So all the performance attributes of our dress shirt were being mitigated. And so we found it was really important to create that entire experience. So we create a moisture-wicking undershirt or base layer and a dress shirt. So one of the things we wanted to look at was, again, we're outsiders to fashion, and that gives us a totally different approach and perspective. One thing that's been really big in manufacturing is this concept of lean manufacturing. And opposed to optimizing production, it's optimizing or minimizing waste. This actually ended up turning into a startup methodology called the Lean Startup. Eric Ries kind of popularized it recently. But it's been really prevalent in the Web 2.0 space, where basically what it means is you build something, you test it, and you fail fast. And the key thing is you're trying to optimize learning and do it as quickly as possible. So for example, let's say you're designing a website. What a lot of people will usually do for user experience is they'll present two different home pages to the website, and they'll figure out which one users respond better to. We're doing the same kind of thing. We're taking a lot of these practices and applying them to product design. So one thing is, with our dress shirts, we found that we could spend a lot of time in R&D trying going down the rabbit hole and figuring out what's the perfect fabric, and kind of based on theory. But at the end of the day, we found out that comfort is completely subjective, and it's really up to the customer to tell us that. So what we do is we actually, for our product developments, we actually had 3 different colors here of shirts that we sold. And actually, each color is a different fabric. It has different coatings, different knitting properties. And what that allows us to do is test those different properties. And we think it's independent of color. And the key thing is we sold these shirts, and we got the feedback from our customers. And nothing is more candid than an actual customer telling you, which fabric works better. And from this, what's core to our brand is this part of our materials. And from this, we were able to figure out what combination of coatings, knitting properties that we would need in our own proprietary fabric. So instead of investing $10,000 to $15,000 in developing the fabric up front, we had our customers help us develop it. Another thing is, looking at packaging, we really tried to figure out a lean method of creating the packaging that we actually scaled for different size of products. Basically, instead of paying, putting in an order for 10,000 boxes, we actually did smaller batches of 100. And while we pay a premium on that, it allows us to change our product very quickly. And finally, in the fashion space, again, it can take a year to develop a product. For us, we're doing a couple things. We're manufacturing our fabrics in California, and we're creating our dress shirts right here in New York in the Garment District. That allows us to have a really fast turnaround, and we can go from not having a design to having shirts on our racks in 4 weeks. So this is a big change and totally different from what's happening at big retail stores. And finally, so the last thing I want to talk about is this idea of customer engagement. And what we found is our customers are probably one of our best resources. So our early customers have bought our shirts. They tell us what they think about it. And the best part is it really creates brand loyalty because they feel like their input, their comments are actually affecting our products. And so that's what I want to talk about is just think about, even if you don't have an engineering background, let's say, you can go into an engineering field, let's say in biotech, and have a different perspective. And that can really allow you to change your product or that company in not just an incremental way, but actually a revolutionary way. So thanks.
So about a year ago, I was at the Metropolitan Museum of Art, and I walk in, and there's about a 30-minute wait to get my tickets. And I was like, okay, this stinks. I only had about 2 hours there, and I'm in line for about a minute, and I see another ticket booth in the corner. So I walk over and I say, ma'am, can I buy my tickets here? She said, go ahead. I said, well, what's the catch? I don't have to wait here, but over there I have to wait for 30 minutes. And she said, I've been working here for 3 years. And every day people walk in, they get in that same line, and they'll wait there for 30 minutes, an hour, 2 hours. And you wonder, why do people do this? Why do we get so caught up in the little details? Oh, there's a line, I'm gonna go stand in it, instead of stepping back and looking at the big picture. So today I'm gonna talk about the one weapon we have against the PhDs, the MDs, as college students, recent grads. So when we go and attack entrepreneurship in the hard sciences, how we can pioneer in this field. And the one thing is the fresh perspective, the new ideas we can bring to a field. In college, you're taking classes in art history, animation, computer science, and you can bring those to biology, you can bring them to engineering, and that is what it's all about. And so, for example, a PhD in, let's say, the snail circulatory system, they've been studying the snail for about 40 years, they're not gonna think that this one chemical that they've been looking at could be used in cancer or could be used in diabetes. So it's really important that as young students, we do have the ability to see into different fields and how we can bring it into our own studies and our own interests, and especially our own passions. So I'd like to introduce you to Macrovax, and now this is my venture in the cancer vaccine industry and space. And how it works is it's a vaccine that teaches your own immune system to kill the cancer. And that's funny because this whole time, over 40 years ago, President Nixon declared war on cancer. And still today, we use chemotherapy and radiation as the primary forms of treatment. Now, the answer's been inside of us all along, which is really interesting. So how I got into this and kind of how Macrovax works, what are cancer vaccines? Now, in the tumor microenvironment, in the area around the tumor, there is a biological stop sign, chemicals that suppress your immune system. Now, what the cancer vaccines can do is they can remove that barrier and allow for immune cells to infiltrate the tumor and destroy it. So that's all you're doing is you're removing that barrier to allow your body to carry out its natural processes, and it creates a happy patient. So how did I get involved and where did I come up with this idea? So as a kid, I was really interested in marine organisms. So I was watching this NOVA research special on horseshoe crabs. They're about 300 million years old, and how their immune systems work is when they become bacterially infected, their immune cells form a clot around the bacteria and they secrete this binding protein. And what this binding protein does is it signals the immune cells to destroy the bacteria. So I thought, okay, cool. How about we find a human analog, load this with the patient's tumor cells. Could we disguise your tumor as a bacteria? Would your body be able to treat the tumor as a bacteria, process it, and go ahead and go kill it with the T cells and necessary immune cells? So here, I'll go back. Now, I came up with this idea, kind of just sketched it on a notepad and brought it, this was when I was in high school, it was in my junior year of high school, and I brought it to the teacher and said, hey, this is my idea, I'm really excited, I'm gonna use mice, I'm gonna do this, I'm gonna cure cancer, whatever, and they said no. They're like, you're not gonna do that, you're not gonna use mice, you're not gonna be able to do that, and I was about this close to giving up. No one had ever told me that an idea wasn't worth pursuing or wasn't even gonna become anything. And what got me going was that no one had ever told me, no, you can't do anything. And what I did was the next best thing. Instead of using mice, I used octopi and starfish. And all I wanted to do is show that my vaccine, that thing that I showed you, I drew it on the board just for reference, how it signals the immune cells. All I could do is I took a human vaccine, I made it with human blood, human serum, injected it in these starfish and octopi, I could elicit immune response. And what that looks like is all the immune cells will move to that area of injection. So I pitched this idea to biotech companies, raised a couple $1,000s for initial studies, called Georgetown University, got into the research lab to do the imaging, and kind of walking in there with this big fish tank, there's octopi like spewing ink everywhere, and everyone's just kind of looking around like, what are you doing? Like, this doesn't even make sense. No one uses these anymore. We use mice, remember? And this was the first image we got. And what really blew everyone away was the fact that I took a human vaccine, injected in this thing that doesn't even have eyes or anything, and watched their immune cells all become active. And that's when all the scientists said, okay, maybe this is worth pursuing. And that's when I got my own lab space at Georgetown, raised $10,000, up to now $20,000 of funding to pursue this. And now we're up to the stage of Immuticon. And I don't want to go into all the research of proving this in mice, showing that we can elicit an anti-tumor immune response, that when I do inject the vaccine, you can watch the tumor just dissipate and shrink. What I want to tell you about is the journey and about what I'm doing right now to further pursue this and what I believe you guys can do to do exactly like this. Now, Immuticon is a biotech company. It's a licensing company where we have the patent, we have the intellectual property, and we're licensing it to biotech companies. Now, how this kind of got rolling was the former senior vice president of Pfizer. He heard about my research and he said, no, this isn't just for cancer. You can load, yes, the tumor antigens, maybe HIV antigen if we find one, or dengue fever, or if a company wants to update their patent, or if they have a vaccine that works kind of well, this will make it more effective. So he sees this as a platform and a licensing model, and that's how Immuticon got started. And really, ultimately, what I've learned two things from this whole experience. One is the complex interaction of the various institutions of our world. You see, when you filed for the patent, working with those lawyers, those things are about 200 pages, and there's every biomolecule on Earth covered in it. And if you just miss one, that lawyer will catch it and it'll tell you that you missed it. And that could cost you your whole patent, because another company could say, oh, well, they didn't include that. We can add that and have a totally new patent and pursue it, and then you lose because you don't have any money. And not many people are standing behind you with respect to Pfizer and some of these other bigger companies. And also you have the FDA looking at clinical trials, also preclinical trials in mice, make sure abiding by all these various rules. And that's why I feel entrepreneurship is so great, because you're learning so much about the various interactions of the institutions. Now, the second part is the human aspect. And I really was blindsided by this because I wasn't really thinking about what I was doing. I was so focused on the science and the technology that when I was asked to speak at Relay for Life in the chapter in my area, I got up there, I was talking just like with you guys, cancer vaccines, nanotechnology, and I'm watching people start to cry. And I'm realizing that whether or not this is anything, whether this is a new treatment or therapy, or if this will make a difference, that I am in an area where we're furthering research that could potentially one day help somebody. It'll help the woman in the audience who wants to be a mother to her children, or the father who wants to walk his daughter down the aisle. And I think that's where the passion comes in. I think that's what gets you up every day. That's what drives you to stay long hours in the lab. And that's what I think everyone needs to find, is their passion. What makes them move forward. And this is where we come in. Because when you believe in yourself and you believe that you can do something like this and you enable yourself to do so with the proper resources, is when you are able to do anything. You can pursue something that helps people in Africa, bring water. You can work on furthering a disease, or especially there's one kid who's working on decreasing the cost of a mass spectrometer to help find a new HIV antigen. So there's a lot you can do to impact society and also pursue your academic interests and see how you can kind of fit into the big picture of solving a global problem. So I kind of put together a list of things that of ideas I've collected from speaking with scientists, engineering students, et cetera, about entrepreneurship and how they went about it, their stories, what they believe are the key aspects that help them. So here's the Everest, kind of going back to the theme of the presentation. And I think the big picture, that new perspective, is what drives this whole process. Now, it starts with the individual, who you are, what you believe in, your strengths and your weaknesses. Then it comes the idea, and I'll talk a little bit about how you can find that idea. The team, that's important. A lot of kids forget that. They think they can do this all on their own, and that's not true. And you have to realize you are in an incubator in universities, or whether you work at a university, because the amount of resources are inexhaustible. The network, how you as a team can build that network and start to bridge connections and carry your company and your idea to the next level. And finally, success, which is honestly, it's about the journey. It's about getting up there. It's not about what happens at the end product. It doesn't matter how much money you make. It matters this whole journey of getting up there to actually having a product, getting in front of the VCs almost on your knees saying, I believe this idea is worth pursuing. I'm 110% behind this idea. And I believe that is the true meaning of entrepreneurship. For example, John Crowley, his children were diagnosed with Pompe disease. He dropped everything, started a company, and cured his kids. This disease was incurable. It was nowhere near curing, and he did it through entrepreneurship. And that's what I believe people forget. It's not about, oh, we're just going to start a company, make a lot of money. There's actually a real application here that's going on, and that's what I really feel like people are missing in entrepreneurship. And we honestly need to bring that back to reality, is this is what it's all about. It's about that human application. And for us, it's the only weapon we have is the fresh perspective that we can bring to all these different fields. So here are some steps you can take. I kind of threw these together. The one that I really think is key and people don't think about is the journal. Just keep a little notebook with you at all times. Write down anything funny, anything that makes you angry, any great idea. Because over time, when you start reading through this, you'll start to see things piecing together. Also, be creative. That one part of your brain is never used. Every day, find other people who are interested in something creative and just talk. See how people stir your emotions and get you excited about things, and that's really important. Also, when you're finding that idea, this is tough, and I think exploring other fields is really important. You know, take your science classes, get all those out of the way, but go take an art history course, go take an animation course, because that is key to bringing those fields and those perspectives to the sciences. Because any great scientist is also a good artist, a good musician, and there's a reason for that. It's because when they go into those fields and they expand their minds and become creative, they apply that to the sciences, and that's when they find something really innovative. And just to end, I want to say that everyone's an entrepreneur. When you're born, you are constantly trying to change your own world, further your own mind, your ideas, and I believe we lose it over time because of our society. It's all about getting the job, learning the courses, getting the grades, and people need to unlearn, and they need to realize that that's not what it's all about. There's a bigger picture, and that's more important sometimes than getting those grades. You can do that too. I do not believe everyone needs to drop out of school and start a company. I believe it's more about balancing your life, learning how you can fit that into your schedule, and also make a difference. So I believe that I want to end with this, just saying it's your turn. That honestly, we all have our own passions, our own ideas. We just need to explore them. Do some introspection, learn more about yourself and how you can further your own passions and emotions to turn them into an idea and a product. And I believe for me, it was the marine biology, and then I started realizing that I actually could help somebody and could make a difference. And I think that's the big picture, and that's what entrepreneurship is all about. So thank you for your time. I'm really happy to be here. So.
If you are interested in joining this whole movement towards entrepreneurship, there's a lot of stuff going on here at NYU. This is only one piece of the puzzle. You saw Larry's class, that's another piece. Go to nyu.edu/entrepreneur. There are, again, a plethora of resources up there. If you go to For Entrepreneurs and then you click on resources, you'll find everything from Steve Blank's blog to different incubators in the city, different books that you should read, other funding sources, and events going on here at NYU. So on Twitter, we're at NYU Entrepreneur. I can throw this back up. And in the meantime, I encourage you to stay here with us. You've stayed this whole time. Go outside, eat your dinner outside. There's plenty of food. And talk to each other. You might find someone here that matches interests. You might be able to exchange a contact with someone. But thank you for coming out tonight. And if you have any questions, you can contact me again at samsmith@NYU. And a few of our speakers are still here, so please bombard them. And that's it for this evening. Thanks, everyone.